This is going to be a tutorial on how to operate the ZK-PP2K pulse width modulator when used for DIY PEMF applications, whether it happens to be a unit you built for yourself or you are using one that may have been built for you. This will cover the usage of standard mode for these applications. When plugging in the unit, the display will automatically turn on. There is an on button at the bottom right of the module that, when pushed, will toggle the word out that you see on the left side of the screen. When the out is being shown in the middle left side of the screen, that means that the system is actively sending power to the coils with the current settings. When you do not see the out on the screen, that means that the power is cut and power is not being sent to the coils. You'll see that the readout will show you for 4 character placements on the top for the frequency and 3 on the bottom for the duty cycle percentage. There will be a percentage sign on the right side of the screen, which will confirm that you're in the correct mode for standard operation. If you do not see a percentage sign on the screen, that means you're in a different mode. If that is the case, and you're unsure of how to switch modes, just press and hold the set button until the screen changes to show the percentage sign. This is actually how you switch between modes, which I will cover more in a different video. To adjust frequencies in standard mode, you'll press the plus or minus buttons on the left side of the module to increase or decrease the number you see on the top of the readout for your desired frequency in whole number values. If you want to enter a larger number and don't want to sit around pushing the plus button however many times to reach that value, you can push and hold the plus or minus buttons to scroll through the numbers quickly. Now, you will see a decimal place on the top readout. This effectively works like a comma when entering values that increase into the thousands. Once you reach 9,999, and then go that last digit over to 10,000, you will see the decimal place shift over in order to fit the value onto the screen. It does scroll pretty quick. The decimal is right by the 9, and then it shifts over. As you increase the numbers, understand that you'll be losing a range of adjustability, starting with the ones place, then the tens place, and so on, as the decimal place shifts. Most frequencies I've encountered during my research to this point don't typically go past the tens of thousands unless in fairly specialized applications. Just understand that the last character placement on the readout that gets scooted off the display due to lack of room will be a 0. That means you are effectively losing that range of adjustability for the number placements that are not visible. So at 1001, with the decimal place between the zeros, signifying you're in the 10,000s, it would actually read as 10,010 hertz. And this is at 1% duty cycle. That's how you would read that. Now for the duty cycle. The duty cycle is how long power is being sent to the coils per pulse, or the on time per pulse. Above 5%, the coils will start to create heat. Below 5%, not much heat, if any, is created, since the coils cool down quickly enough as to not retain that heat, as long as they're pure copper. This means if I were to set the system at 1 Hertz, or 1 pulse per second, as you see here, with the duty cycle at 10%, then the power is being sent to the coils for 1/10 of a second for every pulse. So if the system is set at 1 Hertz and the duty cycle is at the maximum recommended setting of 25%, then that means that the power is being sent to the coils for 1/4 of a second for every pulse. Just as a note, the maximum recommended duty cycle setting is 25% for high heat if you desire that. If you increase the duty cycle above 25%, the coils will create a significant amount of heat, and the risk of damage to self or property will be a significant risk. Works just like with an electric stove that turns on and off to maintain temperature to the stove coils. The longer the amount of time that power is being sent to those coils, uninterrupted, the hotter the stove coils will get. Due to the amount of power being used on a stove, you can usually actually hear when this happens. This works exactly the same way when creating heat with the copper PEMF coils. With that safety precaution in mind, that concludes the instruction and explanation of standard mode for DIY PEMF applications.